For the next minute, focus on this. The Vikings did not survive the North Atlantic world because they were reckless warriors or fearless explorers. They survived because their homes were engineered with a level of environmental logic that still outperforms many modern cabins. While we tend to picture them as rugged people simply enduring the cold, the reality is more interesting. Their longhouses were so well designed that even in Icelandic winters, Greenland storms and Norwegian mountain valleys, they retained heat to the point where a single central fire, often burning low, was enough to keep families alive through the darkest months. What makes this worth your attention today is that the same construction principles still work perfectly, even with modern materials, and they don't require electricity, forced air heating, or metal stoves. If you're the kind of person who values techniques born out of necessity, not theory, this is one of the most enduring pieces of old-world engineering you can study. The basic Viking longhouse design created natural insulation and heat retention. Viking longhouses were built low to the ground, with heavy turf walls and timber frames. This wasn't a stylistic choice, but a practical adaptation. Thick sod acted the same way as a natural super-insulator. Turf starts as layered soil and roots, but once cut and stacked, it traps air pockets that slow heat loss. In a world where temperatures dropped well below freezing for months, turf walls could be more effective than early brick or thin timber structures. For someone today building an off-grid cabin or even insulating a shed, the same principle applies. Thick, dense walls matter more than decorative materials. If you stack earth bags, straw bales, or even homemade adobe, you're recreating the thermal mass that made Viking homes so stable. With enough thickness, usually 2 feet or more, you dramatically slow down temperature swings. Heat lingers for hours, and cold takes much longer to penetrate. A detail rarely mentioned in casual documentaries is the slight depression of Viking longhouse floors. Lowering the floor created a pocket where warm air settled naturally. The coldest drafts skimmed above the living space instead of slicing through it. This wasn't accidental. It was a deliberate way to control airflow long before mechanical systems existed. This has a direct modern application. If you create even a small drop in the main living area of a shelter, whether with temporary platforms or by digging down, you trap warm air where you sit and sleep. It reduces your need for constant heating and increases comfort noticeably. This is especially relevant for anyone building emergency shelters, root cellar-style cabins, or winter workshops. Heat rises, but it also settles into low zones, and you can take advantage of that the same way the Vikings did. The Vikings' central hearth was more than a fire pit. It was the heart of the house, built in the centre so its radiant heat spread evenly in all directions. Stone or clay lining preserved heat long after flames died down, and the slow-burning fire created a stable temperature without the wild fluctuations that modern fireplaces often cause. When applying this today, a low, ember-based heat source is far more efficient than tall, flashy flames. If building a fireplace, fire pit, or rocket mass heater, the principle remains the same. You want something that radiates and stores heat, not something that burns fuel quickly and sends all the warmth up a chimney. A long-lived ember bed combined with stone surroundings can keep a small cabin or room warm through the night. Viking roofs were steep, supported by wooden beams and heavy with turf on top. This accomplished 2 things. It prevented snow from collapsing structures, and it created a trapped upper layer where warm air accumulated and slowly radiated back down. The turf roof acted as another insulation layer, often thicker than the walls. If you're trying to create a warm, energy-efficient home today, roof insulation is the single most important area to focus on. A thick layer, whether it's modern insulation, packed straw, or sod, prevents heat loss better than insulating walls alone. Many off-grid builders still use green roofs because they naturally create the same effect the Vikings benefited from. The long, narrow design of Viking houses restricted cross-breezes. Entry points were small, often deliberately offset, instead of placed directly across from each other. This controlled airflow, reduced heat escape, and created pockets of warmth around the hearth and sleeping areas. In practical terms, anyone designing a small cabin or workshop can adopt the same strategy. Avoid placing two doors or large window openings directly opposite one another unless ventilation is the goal. By staggering openings, you prevent strong drafts and maintain internal temperature far more effectively without having to increase fuel consumption. Human bodies give off a surprising amount of heat, especially in insulated spaces. Viking longhouses often housed extended families, livestock in winter months, and visitors. Combined with the thick walls and central hearth, this produced a stable interior environment where temperatures remained survivable even during storms. This principle still works. In emergency situations, keeping people together in the warmest part of a structure saves fuel and reduces heat loss. Even working in a small room with a closed door instead of an open workshop changes heat retention dramatically. The Vikings understood this intuitively because survival forced them to. What makes the Viking home design enduring is that it worked with natural physics. It didn't resist the environment, it used the environment. Thick walls, earth insulation, central heat, airflow control, and interior heat sources created a dependable system without relying on tools or technology. If someone today builds a modern longhouse, earth-sheltered cabin, or even a sod-roofed studio, they are following the same design logic that kept Norse settlers alive in Iceland and Greenland. It still works because the principles don't change. If this exploration of Viking winter engineering added something valuable to your understanding of ancient survival architecture, make sure you subscribe, share this guide, and join the community of history enthusiasts who appreciate practical knowledge that stands the test of time.